All right, let's talk about variables. Seriously, what if I told you that there are 7 specific variable patterns that literally separate amateur coders from pros? Well, there are, and by the end of this, you're going to know exactly how senior developers at top companies structure their code to build applications that can actually scale. Oh, and you'll definitely want to stick around, because I've got 3 coding challenges at the end to really put your new skills to the test. Ready? Let's get into it.
So here's the game plan. We're going to cover 7 key patterns, starting with something as simple as loop counters and building all the way up to managing complex application state. Think of these as the fundamental building blocks for writing that clean, professional-grade code that you see in real production systems.
Okay, first up, let's tackle something that seems super simple. But trust me, it's a dead giveaway of a beginner programmer: loop counters. It is absolutely time to move beyond the basics here.
All right, look at this. On the left, we've got the classic rookie mistake. We've all done it, right? You create a manual counter, you increment it inside the loop, and it's just asking for trouble. It's so easy to introduce bugs, especially those super frustrating off-by-1 errors. But now, look at the professional pattern on the right. Python's built-in enumerate function is just so clean. It hands you the index and the item together, all packaged up nicely on every single loop. And that little start equals 1 argument, that's a lifesaver for when you need to count like a normal human, starting from 1 instead of 0.
So you might be asking, why does this really matter? Well, imagine you're processing, I don't know, thousands of files. Your user is just sitting there staring at a blank screen, right? They need feedback. And this is the perfect real-world use case for enumerate. With that index, we can easily calculate a progress percentage on each pass through the loop. This is exactly how applications create those progress bars you see everywhere. It's all about providing a way better user experience.
But wait, we can take this even further. For data analysis, Python's collections module has this incredibly powerful tool called a counter object. Let's say you have a giant list of every purchase a customer made. You can just feed that whole list to counter and bam, it instantly tells you which items are the most popular. E-commerce giants use this exact pattern for their business analytics to figure out top-selling products and keep their inventory in check.
All right, moving on to our second pattern, flags. The best way to think about these is like light switches for your code. They're just simple true-false variables, but they give you incredible control over your program's flow and help you keep track of what's going on.
So, where do you use these? Well, they're perfect for handling complex logic. Think about a sign-up form. You know how annoying it is when you submit a form, it tells you one error, you fix it, submit again, and then it tells you the next error? Yeah, that's bad design. Instead, you can use an isValid flag. You start it off as true, and you only flip it to false if one of your checks fails. This lets your code run through all the validations, username, email, password, everything, and then report all the errors back to the user at once. It's just a way better experience for them. Now, when you take this idea to a massive scale, it evolves into something called feature flags. And this is a professional industry standard for sure. We're talking about how companies like Facebook and Google operate. They can use a feature flag to roll out a brand new feature to just say 1% of their users. And if something goes wrong, if there's a bug, they can instantly flip the feature off for everyone. No stressful late-night emergency deployment needed. It's absolutely essential for A/B testing and just rolling out new stuff safely.
Okay, this next one, this is one of my absolute favorites. It's a pattern that will make your code so much cleaner. Seriously, it's time to finally kill those long, hideous, unreadable if, elif, elif chains. Let me introduce you to dictionary dispatch.
So check this out. On the left, you have that ugly, brittle if-elf monster. Every single time you want to add a new operation, you have to tack on another elf block. The function just gets longer and longer and becomes a nightmare to maintain. But then, look at the beautiful, clean solution on the right. We just map the operation names as strings directly to their functions in a dictionary. Now, if you want to add a new operation, you just add one new key value pair to the dictionary. That's it. It's elegant, it's scalable, and it's just so much easier to read.
And listen, this isn't just some clever little trick. This is literally the engine running inside major web frameworks. When you visit a URL, frameworks like Flask and FastAPI use this exact dispatch pattern to map that URL path to the specific function in your code that's supposed to handle the request. It's at the very core of how modern web routing works. It's fast, it's efficient, and it's incredibly robust.
All right. Let's talk about leveling up the professionalism of your applications with our fourth pattern, centralized configuration. This is all about fixing one of the most common and most painful mistakes I see beginners make: hard coding values all over their codebase.
The bad practice on the left, it's just a maintenance nightmare.
the database port is hiding in one file, the API timeouts in another, maybe the secret key is somewhere else entirely. If you need to change a value, you have to go on a scavenger hunt through your entire project. It's terrible. The professional approach is to have a single, centralized configuration object. This app config dictionary becomes your single source of truth. You need to change something, you change it in one place, and that change is reflected everywhere, instantly.
But here's the real pro move. In the real world, you're not just going to have one setup. You'll have different environments, right? One for your local development machine, one for testing or staging, and then the live production server. This pattern uses something called an environment variable to automatically select the correct configuration dictionary when the app starts up. This is absolutely essential for deploying applications on platforms like AWS or inside Docker containers, where you can't just go in and change the code for each different environment.
Okay, this next pattern is a little more subtle, but it's super important for writing really clear, unambiguous code. We're going to talk about Sentinel values. These are basically special markers you create to signal a very specific condition, like data is missing or item was not found.
Now I know what you're thinking. Why not just use none? And you know what? A lot of the time, none is perfectly fine. But a Sentinel value is a unique object whose only purpose in life is to signal one specific state. And the key benefit here is clarity. What happens if none could be a legitimate valid value in your data? Like, what if a user's preference is explicitly set to nothing? See the problem? That's exactly where a custom Sentinel really shines.
Let's just compare them side by side. On the left, we're using none as our default. But if the database itself could return none as a real value, we have no way of knowing. Did we get none because the key was missing, or because the value stored in the database was actually none? It's ambiguous. The custom Sentinel on the right, our not found object, completely eliminates this problem. When you check if result is not found, your intent is crystal clear. There is absolutely zero confusion.
All right, let's move on to pattern number 6, state variables. And the absolute best way to understand these is with an example literally everyone is familiar with, an e-commerce shopping cart.
Think about it. A shopping cart is the perfect example of an object that needs to manage its own internal state. When you, the user, add an item, internal variables like the items list and the subtotal have to get updated. When you apply a promo code, maybe a discount applied flag gets flipped to true, and the promo code itself gets stored somewhere. Every single action you take modifies the internal state of that cart object.
And here's what that looks like under the hood. After a few operations, the cart's complete state is just a collection of all these different variables working together. You've got the list of items, the subtotal, that discount flag, the promo code, and the final calculated total. All of them together create a perfect snapshot of the cart's current state. And make no mistake, this is exactly how sites like Amazon and Shopify manage your order behind the scenes.
And that brings us to our 7th and final pattern, accumulators. These are the workhorse variables that power pretty much all data analysis and business intelligence. Their whole job is to collect and aggregate raw data into something meaningful, into actual insights.
Just take a look at this sales analysis function. See how we initialize several different accumulators right at the top? We've got total revenue starting as a float, product revenue as an empty dictionary, and so on. Then, as we loop through all that messy, raw sales data, we accumulate the values into these variables. We add to the total, we update the counts in our dictionaries. This right here is the fundamental process of turning a pile of raw data into clean, structured metrics.
So, after our code crunches through all the data, our first accumulator gives us our first key metric. This is the big number you'd see right at the top of a business intelligence dashboard, the total revenue.
And that dictionary accumulator, the product revenue one, that can be instantly transformed into a visualization, just like this bar chart. I mean, this is precisely how business intelligence tools work. They use these accumulator patterns to process mountains of raw numbers and then present them in a way that gives you real, actionable insights, like, oh, look, that's the product generating the most revenue for us.
All right, we've made it through all 7 patterns. We've covered a ton of ground. Now it's your turn. It's time to prove you've actually learned this stuff. So I've put together 3 coding challenges specifically designed to help you apply these new skills.
First up, we've got an easy one. Build a task manager. This will get you using lists, flags, and counters. The medium challenge is to create a smart calculator. This is perfect for practicing that dictionary dispatch pattern and managing state. And for the advanced challenge, you're going to design a full authentication system which will force you to combine configuration, state management, and even feature flags.
Look, mastering these patterns will fundamentally change the way you write code. I promise you. You'll start producing cleaner, more maintainable, and just all-around more professional applications. So I'm curious, which pattern surprised you the most? Or which one are you excited to go try out in your own projects first? Drop a comment below and let me know.
And hey, you can download all the code you saw here, including the full solutions to all 3 of those challenges, from the link down in the description. If this helped you level up your Python skills even just a little bit, do me a favor and hit that like button and subscribe for more professional coding content just like this. Thanks so much for watching, and keep on learning.